So from the second set of problems that you sent, uh, most of the problems revolved around the concept of series, which is the idea of adding up terms that are related to each other, either through adding to get from one term to the next, or by multiplying to get from one term to the next. Some of them were what are called finite, meaning we know exactly how many terms that we're adding, and some were infinite, meaning there are an infinite number of terms that we're adding up, which we can only do sometimes. So the two series types are what are called arithmetic and geometric. Arithmetic means that you're adding the same thing every time to get to the next term that you're adding on. So this would be if I were saying that I'm adding on, we say D for a common difference. If I were adding on 3 each time, I'd have one. I could say I start at 1 and then plus 4, plus 7, plus 10, plus 13, and so on. This would be an arithmetic series because to get to the next term I'm adding on, I added a 3 to the previous term. So 1 plus 3 gave me 4, 4 plus 3 gave me 7, 10 plus 3 gave me 13, and so on. With arithmetic series, if there's a finite number of terms, meaning we know how many terms there are, we can add these up, and there's faster ways of doing it than adding it up by just writing out every single term. First, we would need to know the last term we would want to. So to find any term, if we know the first term and the common difference and how many places we want to go, which is what n stands for. N stands for the place value within our series of if I wanted the 10th term, n would be 10. If I wanted the 1000th term, n would be 1000. So here, if I were doing this series up here where my common difference is 3, and my first term is 1. If I wanted the 100th term, a sub 100 would be my first term plus the common difference times 100 minus 1, which would give me 1 plus 3 times 99. So that's 297 plus 1, which is 298. So that allowed me to find the 200th term. Well, then we even have a formula that allows us to find the sum of an arithmetic finite series, which again, what we would need to know is how many terms, the first term, and then the last term. So if I wanted the sum of the first 100 term of this series, it would be 1/2 times, I wanted 100 terms. My first term was 1, and I just found my 100th term was 298. So this would be 50 times 299, which would give me 14,950. So I have my sum for an arithmetic series. For geometric, the difference here is I'm multiplying by the same thing. This would be a common ratio. So we use R for a common ratio. It's what we're multiplying by to get each term. If I said my common ratio was 3 and my first term was 1, then my second term would be 1 times 3, and 3 times 3, 9 times 3, 27 times 3, 81 times 3, and so on. Well, I can find also how to get to a sum from this, where, or not to the sum, to get to an nth term, I do a sub n is equal to my first term times my common ratio raised to the n minus first power. So if I wanted the 100th term for this, first term was 1, my common ratio is 3, it's the 100th minus 1 power. So this is going to be 3 to the 99th power. In terms of a sum, the only thing I saw involving you actually finding the sum for a geometric series in your problems involved an infinite series. So this is sum of an infinite series. We can find by doing the first term divided by the quantity of 1 minus our common ratio. Remember, the common ratio is what we multiply by to get from one term to the next of what we're adding. Now, the key here to this is this only works if the absolute value of our common ratio is less than 1. So here, since my common ratio was 3, this does not add up over an infinite amount. what we would say is it would diverge because it would actually go off to a value going off to infinity. Whereas if our absolute value of the common ratio was less than 1, our sum would converge to this value. So some of the examples that you had sent here were ones that involved arithmetic series. So we were told I can tell this is an arithmetic series because they say D is 2, and D is my common difference. And if I want to find n when I know that the first term is 1, common difference is 2, and my nth term is 12, what I use is that equation for the nth term. So I can plug in a sub n is 12, a sub 1 is 4, d is 2, and then subtract 4 from each side, divide by 2 on each side, add 1 on each side, and n is my 5th term. And I can even write that out and double check it. I wouldn't recommend wasting the time here, but first term was 4, I added 2, second term was 6, third term was 8, fourth term was 10, and yep, fifth term was 12. So it does check out. A little more complicated was the one involving the theater seats. So a theater has 35 seats, 35 rows of seats. What that tells me is n is 35. First row is 23, so my first term is 23. My second row is 27, so that went up by 4. Third row has 31, that went up by 4 again. So I actually can see adding 4 each time I go to another row of seats. So that means my common difference is 4. If I want to find how many seats in the theater, that means I'm trying to find the sum, which would be 1/2 times n times a sub 1 plus a sub n. I know what n is. I know that n is 35. I know that a sub 1 is 23, but the problem is I still need a sub 35. But I have a formula that lets me find a sub 35. And that would be my a sub 1 plus the common difference times 35 minus 1, which would give me 159. So now I can plug that in here. I have 1/2 times 35 times 23 plus 159, which gives us a total of 3,185 seats. In terms of geometric series, one that was there was finding the nth term of the geometric sequence, and they told you it was geometric. So what we need there is we need to know that our first term is 1, and then I need to figure out what am I multiplying each term by to get to the next. I see, well, 1 times 4 gives me 4, 4 times 4 gives me 16, 16 times 4 does give me 64. So my common ratio is 64. So then if I want the nth term, that's a generic one, so I just leave it as an end. That would be my first term, 1, times the common ratio of 4, raised to the n minus 1 power, which I don't need to write the 1 there, so this could just be written as 4 to the n minus first power. And that would be my nth term in the geometric sequence. For the other one here, where it just said find a sum if it exists, this is an infinite series because they don't tell us what the last term should be. But they don't tell me if it's arithmetic or geometric. But I can see, well, if they're arithmetic, I'd be adding a negative 140 to get to 35, and then negative 140 doesn't give me 7. So then I think, well, what about multiplying? And I can see that what most people see is they say, well, I divided by 5, and then I divided by 5, so I'm dividing by 5 each time. But a geometric series is always multiplication, so we change the division into multiplying. If we think in terms of fractions, dividing by 5 is the same as multiplying by 1/5. So this is the same as saying times 1/5, and then times 1/5. So what I have is a common ratio of 1/5 and a first term of 175. The if it exists part is important because I need to check, is the absolute value of 1/5 less than 1? Yes. So this converges. So the sum converges to that value of our first term divided by quantity of 1 minus my common ratio, which is 175 divided by fifths, which is the same as 175 times 5/4, which gives me a total here then of 218.75. I believe that hits all of our series. And the next video, I'll start dealing with those combinations, permutations, and probabilities and binomial expansions.